Hello, good afternoon everyone. I'm Miriam Ugarte from Mondragon University, and today I will be presenting the work that will be carried out, which is the implementation of a digital twin-based virtual commissioning in the machine tool manufacturing industry. And that the work has been carried out in collaboration with Techniker and IDECO, which is the research center unit of the Novato Group machine tool builder, and is being developed under the DMAND Horizon 2020 project. Okay, we know that Industry 4.0 has brought smart factories, IoT, physical systems, and digitization of production systems in which we have new technologies emerging out there to respond to market needs. In this context, digital twins are considered as the next wave of simulation technologies, in which virtual commissioning practices can be further boosted through the whole product life cycle. These marine technologies, however, have little implementation in the machine tool industry. Recent studies show that companies are reluctant to invest in simulation technologies. They argue that efforts to generate simulation models are not justified in terms of return on investment. And on top of that, interoperability and standardization of vendor-specific tools is a major barrier when integrating all these simulation theories together. So to address this, we have developed a digital twin-based virtual commissioning solution at the Novat Group to respond to the machine industry needs. Okay, so first we need to understand the machining industry requirements. So we have defined on one hand a simulation platform that includes virtualization solutions, not only for a single CNC, but for multiple CNC controllers. Then as a second requirement, the simulation platform of concept design should include various engineering disciplines, such as the mechanical system, automation, and control, where we have a CNC emulation model, PLC emulation model, and then 3D model. And lastly, it should be a holistic platform that integrates all these diverse simulation models into a single environment. We use a single hardware. So this should be vendor independent, where we have vendor A, B, C, all these simulation models working together in a single environment. So our main objective was to address all these requirements. So we developed a virtual commissioning solution architecture to respond to these needs. Okay, so virtual commissioning, briefly, we know that virtual commissioning practices are used early in the development process. Why? To minimize errors and reduce commissioning costs and time to market. For this, we have different solutions, alternatives based on the virtualization solution. For example, reality in the loop, which is not so known nowadays, but it uses the actual mechanical system, I mean the real one, and replaces the real controller, by a virtual model. Then we have a hardware in the loop, where replaces the mechanical system by a simulated model that emulates the physical behavior of the real mechanical system. And lastly, software in the loop involves both virtual mechanical system and virtual controller, and it permits adjusting, for example, the speed of the simulation. Since everything we have virtual models, we are not working with the real system anymore, and as opposed to hardware in the loop that is executed in real time. So for this, there are several solutions out there in the market. We have listed some of them and highlighted the technical strengths and characteristics of this one. So for example, we have Siemens, different products from Siemens, Siemens NX, Siemens Cinematics 1, which is the latest one, Process Simulate, and Siemens Plant Simulation for the production line. Then we have Dassault Delmia for the machine as well, robotic cells and industry, ISG Virtuos in the machinery industry, Simumatic 3D, mainly for education, Emulate 3D, and Superior for, yeah. So all these offer virtualization solutions Here we can see the main characteristics. But our aim, our main goal is to benchmark the industry requirements in order to assess the industry needs. So we have just benchmark all these requirements with these existing tools. And as seen in the table, yeah. So we see that there is a large market of visualization solutions, mainly for PLCs, and there is little regarding the virtualization of CNCs, which becomes even a major problem when integrating various CNCs as required under the requirement one, which consists of having multiple CNC controllers. Numeric 1 is the only integrated simulation solution that complies maybe with all the requirements, but this solution is limited to Siemens products, which is vendor specific. So this is a major problem because, well, the major drawback is that the solution does not allow to integrate components from different manufacturers. So to address this, we have implemented a digital twin-based virtual commissioning solution, which is vendor independent, and it integrates all these simulation models into a single and unified platform. Their work has been developed and implemented at IDECO, which is the research center unit of the NOVAT group and provides solutions for the machine tool industry. The proposal comprises of a 4-layer architecture framework as seen in the slide. So it consists of a multi-vendor, multi-controller physical layer where we have machine level and the cell production line, 2 use cases. Then an interoperable middleware for data exchange, multi-vendor sub physical layer, and lastly the application layer. So as well, we can see that I have 2 use cases in the physical layer, and one of the machine layer where we have a single CNC, and then cell production line where we have multiple CNC controllers. Then the cyber layer includes the digital twin of the physical machining tools for my virtual vendor-specific controllers, and as well the mechanical system. The communication between the physical layer and cyber layer is through an interoperable gateway called SAVI. Integrating between all these simulations is vital, so this is key player. And yes, so this is critical. And to date, there is it's not solved to date. So a modular interoperable gateway called SAVI was therefore set up as a middleware. The gateway facilitates information exchange within open standardized protocols such as OPC-UA for the field communication, and then RESTful API to connect to the cloud platform. And finally, at the application layer, we can build up services such as, for example, monitoring services. And yeah, so now I'm going to explain a little bit the two use cases. On the machine layer, we used the Danobat Group FMT Multitasking Machine Tuning Center, and this consists of an individual machine tool. I mean, it has a single CNC, a PLC, a robot controller from different vendors, such as Heidenhain PLC, Heidenhain CNC, and then the robot controller for the robot tool magazine. It's a ABB. So then the cyber layer, the digital twin, should integrate all these virtual solutions into a single holistic platform. And should be vendor independent, as we have manufacturers from different different vendors, Heidenhain ABB. Then the second use case consists of a production line, and which consists of multiple CNC controllers. And this use case was set out to prove requirement one, which was integration of multiple CNC controllers. And in this case, a vending machine and a gantry is used that manages the material flow. So we fulfill all the requirements because for requirement 1, we used the production line, which consists of multiple CNC controllers, and OPC UA is the interface that connects all these tools through an interoperable gateway. Then the second requirement, which was integrating different engineering models, such as the 3D models, automation model, and control model into a single holistic platform. And the third one, all these components were installed and configured in a single PC, so it's also fulfilled, being the only necessary hardware to carry out verification activities later on. And yeah, with this, solution, virtual commissioning can be tested in a collaborative way in a single platform. Major challenges out there in the industry are that so we must deal with different communication protocols and programming environments. For this, we use the interpreter gateway. Then industry claims that time and effort to design models are no longer reusable after the commissioning stage, but this can be sorted out via virtual commissioning. Difficulty in quantifying the return on investment, which needs to quantify this, high cost of licenses, since a major barrier as well out there, and lack of collaboration and synchronization between all these engineering fields, which we think that virtual commissioning, having this in a holistic platform, should respond to this. Major outcomes, so we integrated a broad set of simulation tools and verifiers in a single platform, enabling virtual commissioning of vendor-independent machining solutions, in return reducing errors and shortening time to market. So major benefits, less time to market, as integration permits partial validations early in the development process, so we save the development cost and as well reduce errors. So that's all. Thank you very much. Hope that you enjoyed. And yeah, you have any questions, please don't hesitate to ask me, either online or offline. You have the emails out there, and yeah, we're pleased to answer your questions. So thank you.